Hello everyone, this is Dr. Rajesh and I am again with you with my new video lecture. And in this video lecture, we will also discuss some numerical problem on projectiles. And today's this video lecture's numerical problem is this is the problem: the angular elevation of an enemy's position on a hill h feet high is beta. Show that in order to shell it, the initial velocity of the projectile must not be less than this factor. So firstly we shall see what is the figure of the problem. So this is the figure of the problem. In this figure, if we see that this is the origin and this is the enemy sitting at a h feet high. So this is enemy sitting, this is the origin, and we have to hit this angle of elevation. This is beta angle of elevation, this angle is beta. So now we have to hit this particular enemy, so this will start from here. Now this will hit something like that. So this is the projectile projected with velocity say u. Angle of projection is alpha, and we have to prove that this velocity of projection, initial velocity, must not be less than this factor. So if we see this figure, this angle is in triangle OAB, this angle is 90 degree. So in this case, what will be a height is h. So what will be OB? So OB will be OB upon AB is equal to cot beta. This implies that OB is equal to AB cot beta. So AB is h cot beta. So this distance from the origin is h cot beta. So if I say the coordinate of this is h cot beta comma h, fine. So this is the case. Once again I am doing it from the scratch. We know that equation of of trajectory is given by, so what is the formula for equation of trajectory? It is y is equal to x tan alpha minus 1 by 2 g x square by u square cos square alpha. And since it passes through, this is the trajectory, and it passes through point A, through point A h cot beta comma h, therefore it will satisfy equation of trajectory. Now substitute h in place of y and h cot beta in place of x. 1 by 2 g h square cot square beta u square cos square alpha. This further implies that h cot beta tan alpha minus 1 by 2 g h square by u square cot square beta, and 1 by cos square can be written as 1 secant square alpha. So this thing further implies that h is equal to h cot beta tan alpha minus g h square cot square beta by 2 u square. Secant square is 1 plus tan square alpha. This h is equal to h cot beta tan alpha minus g h square cot square beta 2 u square minus g h square cot square beta by 2 u square tan square alpha. Now try to make this coefficient as a unity. For this we need to multiply with reciprocal of this and negative sign throughout the equation. So multiplying throughout by 2u square by gh square cot square beta minus, we get this will be minus 2 u square h by g h square cot square beta is equal to minus 2 u square g h square cot square beta h cot beta tan alpha plus 1 plus tan square alpha. This further implies that now this will cancel out, one cot will cancel out, so we are left with tan square alpha minus 2 u square by g h cot beta, this is tan alpha, it will be 1 plus 2 u square h g h square cot square beta is equal to 0. Now this is quadratic in tan alpha. So for this equation to have real roots, we should have discriminant should be greater than equal to 0. This implies that b square minus 4ac should be greater than equal to 0. This implies that 2 u square g h cot beta whole square, it will be minus 4 1 plus 2 u square h g h square cot square beta should be greater than equal to 0. So this implies that, this further implies that 4 u4 by g square h square cot square beta minus 4 minus 8 u square h g h square cot square beta should be greater than equal to 0. This implies that 4 is out. Taking LCM, g square h square cot square beta u4 minus 4 is outside, g square h square cot square beta minus 2, it will be u square h, this will be g, and here is the base is greater than equal to 0. Now look over here, 4 is greater than 0 positive quantity, this is always greater than 0 quantity. So for this to be greater than equal to 0, all depends upon this thing. So this further implies that u4 minus g square h square cot square beta minus 2 u square hg should be greater than equal to 0. Now we further see, this implies that u4 minus 2 hg u square is greater than equal to g square h square cot square beta. This implies that now I will try to make it as a perfect square, minus 2 h g dot u square. So I should be adding h square g square minus h square g square should be greater than g square h square cot square beta. This implies that u square minus hg whole square minus h square g square should be greater than equal to g square h square cot square beta. This implies that u square minus hg whole square should be greater than equal to g square h square cot square beta plus g square h square is equal to g square h square 1 plus cot square beta is equal to g square h square cosecant square beta. This implies that u square minus hg whole square should be greater than g square h square cosecant square beta. This implies that u square minus hg should be greater than g h taking square root on both sides. This further implies that u square is greater than gh plus gh cosecant beta. This implies that u square is greater than gh 1 plus cosecant beta. This implies that u is greater than gh 1 plus cosecant beta. Here is the square root. This implies that u is always greater than equal to gh 1 plus cosecant beta square root. This implies that u can't be less than this factor gh 1 plus cosecant beta square root. So this was required to prove that velocity of projection cannot be less than this particular factor. So this much velocity at least is required to hit the enemy, that we have to prove, and we have proved. This is very important question from the examination point of view, so that's why I have covered it in the video lecture. So that's all I have from this lecture. If you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye. Thank you for watching. Bye bye. Take care.